See, next is minor of an element. We'll take an example. Okay, we'll take an example. 2, 3, minus 2, 7, minus 4, 8, 0, 1, 2. Okay, it's a square matrix. See, for forming minor of an element, the matrix need to be a square matrix. The compulsory condition. Matrix need to be a square matrix. If suppose if you are going to find out minor of 8. Okay, minor of 8. This one. Okay, minor of 8. Eliminate the rows and columns corresponding to that. Okay, and the element corresponding to row and column. I am eliminating this row, eliminating this column. So minor of 8 will be what? 2, 3, 0, 1. Find out determinant for this. That is your minor. That particular element's minor is that. So determinant is what? 2 into 1 minus 0, 3 into 0. So which is 2. Suppose if I want to find out minor of 3. Okay, minor of 3, this one. Okay, minor of 3. So what I should do? Eliminate the column and the row corresponding to it. So balance elements 7, 8, 0, 2. And find out determinant for this. That is equal to 14. 14 minus 0. All of the minor, simple. So take that particular element, eliminate rows and columns, find out determinant for the balance matrix. Okay. Right. Not over. Wait. Okay, minor is over. And now coming to cofactor. If I want to find out cofactor of any element, cofactor for any element. For example, here itself, if I want to find out cofactor for 8. Okay, and then cofactor for 3. Cofactor for 8 and cofactor for 3. Cofactor will be equal to minus 1 whole power I plus j into minor of that particular element. Okay, minus 1 whole power I plus j into minor of that particular element. So 8, that is cofactor of 8. 8 is present in second row, third column. So minus 1 whole power 2 plus 3, which is 5, multiplied by minor of 8. So which is equal to minus 1 whole power 5 is minus 1, multiplied by minor of 8 is 2, so which becomes minus 2. And similarly, what about cofactor of 3? Cofactor of 3, minus 1 whole power 1 and 2, so minus 1 whole power 3, multiplied by minor of 3, which is 14, so which is minus 14. So what will happen when summation of I plus j is odd? Summation of I plus j is odd, then my cofactor will be negative of my minor. Okay, summation of my I plus j is even, then cofactor and minor will be same. Okay, clear. And when I plus j will be odd, or else I will write here. I plus j is odd. Cofactor will be equal to cofactor will be equal to minus of minor. Okay, I plus j order, the cofactor is equal to minus of order. So when this is possible? When I and j are odd, when both are odd, when I, j both are odd, or either I or j is odd. Not necessary, if both are even, then it is going to be I plus j. If it is even, then my cofactor will be equal to minor. Cofactor will be equal to minor of e. This is possible when both I and j are even. Sorry, I have written wrongly. So this alone. Here both odd. Okay, there is cofactor. Okay, what about not over? I will complete it. I am going to form a matrix called as cofactor matrix. See, cofactor matrix in the sense, just find out cofactor for each and every element. Find out cofactor for each and every element and take that cofactor, substitute in the matrix. Just take the cofactor and form a matrix. Okay, so cofactor of A11, cofactor of A12, cofactor of A13. That is my first row. Next, cofactor of A21, cofactor of A22, cofactor of A23, cofactor of A31, cofactor of A32, cofactor of A33. This is our cofactor matrix. Okay, the last one. What is adjoint? Just form a cofactor matrix. Form a cofactor matrix and apply whole transpose to it. Okay, that is adjoint. Okay, so 4 terms, but all are like a continuation only. Minor அப்படின்றது ஏதாவது ஒரு எலிமெண்ட் எடுத்து ரோ அண்ட் காலம் எலிமினேட் பண்ணி பேலன்ஸ் இருக்க டேர்முக்கு டிட்டர்மினன்ட் மைனர். Cofactor, I need to multiply with minus 1 whole power I plus j. If any one is odd, okay, if any one is odd, then minus should be multiplied. If both are even or both are odd, then cofactor and minor will be same. And cofactor matrix means just forming a matrix with the help of cofactor. Adjoint is the transpose of cofactor matrix. Okay. I think there is notes not required, but edukku na odara check pannirren enna notes irukku. See, இவ்வளோ டீட்டெயிலாக எதுவும் எழுத வேணாம். இந்த நோட்ஸ் எனிவேஸ் வந்து நம்ம போர்ட்டலில் இருக்கும், நீங்கள் செக் பண்ணி பார்த்துருங்க. ஓகே, ஸோ வாட் ஐ வில் ரெக்கமெண்ட் யூ is just write this definition. Okay, just write this definition. Examples நான் எழுதுனது எழுதிக்கோங்க. I will display that. Definition alone you can write. Examples you can write whatever I have explained. What about adjoint? Sorry, adjoint we found out, right? What about A inverse? Inverse of a matrix. It is 1 by determinant of A into adjoint of A. Okay, A inverse is going to be equal to 1 by determinant of A into adjoint of A. Adjoint of A is nothing but find out cofactor matrix, transpose of it is adjoint. Determinant of A, we know how, we will be finding out how to find out, but basic உங்களுக்கு தெரியும், ஓரளவுக்கு ஐடியா இருக்கும், right? And now, what is the condition here? What happens if my determinant of A is equal to 0? What is the matrix? We will be calling it as singular matrix. If determinant of A becomes 0, if it is a singular matrix, what will happen to my A inverse? It will become, what is that? Infinity, which means I won't be able to define A inverse. Okay, so A inverse is defined only for non-singular matrix. If the matrix is non-singular, then only we can define A inverse. Otherwise, A inverse is not defined. Okay, just wait a moment. Let me check if there is any property. We will go through the properties. If there are properties, we will go through the properties. Examples we will do. Okay, we will solve some problems. Yeah, inverse. See, we already know this definition, right? A into B, what is that? A into B is equal to B into A equal to I, where B is inverse of A and A is inverse of B. Okay, if I find out product of any two matrix and if it becomes I, then B is inverse of A. Okay, so that equation I can more appropriately write it as A into A inverse equal to A inverse into A, which is equal to I, where this B is nothing but A inverse. Okay, other than that, whatever I have already given you. Inverse is also known as reciprocal. This formula we have just now I have given you. நான் சிங்குலராக இருந்தால் மட்டும்தான் இந்த ஃபார்முலா அப்ளை பண்ண முடியும். Okay. Examples, leave it. Examples, just leave it. We will see through questions. Okay, these things I have already said. And also square matrix, minor of element and minor cofactor and inverse. All those things can be applied only to a square matrix. Minor of a matrix we can apply for a non-square, rectangular also. Minor of a matrix, okay, we can apply to rectangular too. Okay, properties. First property, A inverse whole inverse. If I apply inverse and then if I again apply inverse, that is going to become that particular matrix itself. Okay, these are again basic one. This one is something which is very similar to transpose. AB whole transpose equal to B transpose A transpose. AB whole inverse equal to B inverse A inverse. This is second set of properties, right? First I given for transpose, second set of properties. These are also important one. ABC whole inverse equal to C inverse B inverse A inverse. And A transpose whole inverse will be equal to A inverse whole transpose, which I have already given you. Okay, then this non-singular matrix, A and B non-singular matrix are the, then A inverse and B inverse should be same. Okay, they are again pretty straightforward properties. And determinant of matrix, you will see it later. I want to give you one more small formula. See, 3 cross 3 matrix, if it is a 3 cross 3 matrix, there is a shortcut, but I don't exactly know. But adjoint kandupidikkathukku you have to do the complete, you have to find out cofactor for each term, then you have to find out cofactor matrix, transpose it, you will get adjoint. But for a 2 cross 2 matrix, there is a shortcut. Okay, for a 2 cross 2 matrix, the shortcut is here. If it is a 2 cross 2 matrix ABCD, okay, if it is ABCD, then diagonal element just reverse the diagonal element and leading diagonal element. Reverse the leading diagonal element. The other diagonal element, sign alone you need to change it. Okay, sign alone. For example, matrix is 2 minus 3 3 7 or is this 5 7. Okay, if you are going to find out adjoint of A, that will be equal to what? Just reverse the diagonal. So it's going to be 7 2. Sign has to be changed. So minus 3 will become 3, 5 will become minus 5. Okay, sign has to be changed. That's it. That is that is one of the shortcuts which I want you to remember. I will display it at the end. Okay. Now copy this. See, examples and all I will solve, you don't have to worry. I will write down here itself. Okay. What will be A inverse for this? In the matrix, A matrix, A, B, C, D matrix, A inverse. Just multiply this. So 1 by AD minus BC multiplied by D minus B minus C into A. Okay, copy this. Properties na display பண்றேன். முதல்ல இது காப்பி பண்ணுங்க. I will finish determinant also. Okay, determinant முடிச்சிட்டு மொத்தமா question solve பண்ணிடலாம். Determinant and adjoint inverse, A inverse. I will write down, then I will display that matrix. See, A into A transpose, if it is equal to A transpose into A, and if it is equal to I, what actually this statement indicates? In the equation வச்சு என்ன extract பண்ண முடியுது? A into A transpose equal to A transpose into A, which is equal to I. Just now we have what? A is equal to A transpose for symmetric matrix. Skew symmetric matrix, A will be equal to minus of A transpose. Okay, here A into A transpose equal to A transpose into A, which is equal to I. What we can extract from this? Actually, you said the answer, partial answer. Kishore, but matrix name na tappa sonninga. But you said the answer. Matrix name is wrong. Adha solrala matrix name tappu. But what he said is correct. He said that A inverse equal to A transpose. That is something which I can extract from this, right? Because I already know that for A inverse, A into A inverse should be equal to A inverse into A, which is equal to I. So this is universal truth, always true, whatever may be your matrix A. Okay, if your matrix A is a square matrix, then that is true. Okay, but when this happens, okay, when this happens, A into A transpose equal to A transpose into A, which is equal to I, when this happens, then if I compare these two equations, I can say that A inverse and A transpose should be same. Okay, that type of matrix is what our orthogonal matrix is. Okay, so orthogonal matrix is a matrix such that your inverse of a matrix and your transpose of a matrix both will be same. Okay, that will be there anyways. Your A into A transpose will be equal to A transpose into A, which is equal to I. So your A transpose and A inverse will be same. I have given you one example also. You can try it. You can try it means you can just solve. You find out the value. You will get it. And this is the extra note point. You can add that also. You can copy. Nothing is there. Orthogonal matrix na enna therinjikonga, because I have one property associated with orthogonal matrix. Determinant enter anadukku appo or property irukku, that is why. Just know what is orthogonal matrix. If you want to prove this, find out A transpose for this, find out A inverse for this, and that A transpose and A inverse will be same. Just note mari eldikonga, note orthogonal matrix, you can write down. We already know what is meant by determinant. First and foremost, I can find out only for a square matrix, and if I am going to find out determinant for a square matrix, we will use a symbol which is similar to modulus, okay, but it is determinant. So if I am finding out, suppose if I take a matrix 3 0 3 minus 1 4 0 0 1 3 2 4, okay, if I am going to find out determinant for this. What is the general procedure method? General method, I will take first row and I will take each element, and corresponding to the element I will find out cofactor, not minor. Corresponding to the element I need to find out cofactor. So first row, first element is 3, and cofactor corresponding to the element is what? It is first row, first column, so the power is 2. So minus 1 whole power 2 will be positive only. Cofactor and minor will be same. Okay. So minor of this 3 is, I will do one thing, 0, 1, 2, 4. So I have taken the element, I have found out the minor, multiply them. Product of the element and its minor. Okay. And add with next element's product of that particular element and minor. What is the, minor of this minus 1? Eliminate this column, this row. So it is going to be 0, 1, 3, 4. Multiply with the element is minus 1. Okay, but what is the problem here? Element is minus 1, but that is minor, right? That is minor. I want to multiply with cofactor. So first row, second column, cofactor will be minus of minor. So I need to add minus, here minus, but minus into minus it will become plus. Okay. So first it is simply plus. This minus is coming into play because this is minor multiplied with minus will give me cofactor. Third, first row third, that will be plus only, plus 4 into 0, 0, 3, 2. If I solve this, just let me solve it. 3 into 0 minus 2, this becomes plus 1 into 0 minus 3, this is 4 into 0. So that's going to be minus 6 minus 3, which is minus 9. Okay, but I am just going to change one small thing here. You don't need to take first row always. First row எப்பவுமே எடுக்கணும்னு அவசியம் இல்லை. But generally first row எடுத்து பழகிருப்போம். You would have habituated by taking first row. But try to take any row or any column. You can find out determinant for any row or any column. Any row, any column in the sense, choose the rows which has more number of zeros. The rows which has more number of zeros will become more convenient for me. For example, the same problem, if I find out determinant about second row, what will happen? It is 0, right? So it's going to be 0. Next one is 0, that is going to be 0. Plus 1. What about the element? It is second row, third. So instead of plus, I will have minus 1 into, eliminate this and this. 3 into 2, 6. Minus of minus 3, it becomes plus 3, which is minus 10. Okay, so எந்த row column ல நிறைய 0 இருக்கோ அந்த row column எடுத்து solve பண்ணுங்க determinant கண்டுபிடிக்கிறதுக்கு. Okay, that is what. Okay, definitions and all you can write down later. Just a moment. Properties are very, very, very important. Okay, determinant oda property ரொம்ப important. Where it is? Okay. Okay, we can start with the first property. See, do one thing, because property வந்து parallel copy பண்ணா better இருக்கும். Okay, because I will write down some, so அதையும் சேர்த்து copy பண்ணிக்கலாம்ல. Just write down the definition. This definition, this alone, this 3 lines alone. That 3 lines alone will be fine. Example, you can write down whatever I have given. Okay, write down properties of determinant. So ஒரு slide proceed பண்ணுவோம். Okay, parallelly copy each slide. That will be better. And slide copy பண்ணும்போதே அந்த property proper படிச்சிட்டு copy பண்ணுங்க. Very, very important. All the properties are very important. You will have like around 13 to 15 properties, okay, overall in determinant alone. Okay, so A is a square matrix. Obviously I have to find out for a square matrix. Determinant should be determined for a square matrix. If I take a matrix something like this, A B C, some D E F. Okay, and if I try to find out determinant for this, okay, which means it is having identical column. 2 columns are identical. If 2 columns are identical and if I try to find out determinant for it, that will become 0. Not necessarily 2 columns are 2 rows. If they are identical, their determinant value will become 0. Next, if I focus on this, I will use determinant of a scalar. What is meant by a scalar matrix? Scalar matrix, diagonal element. It's a diagonal matrix where my diagonal element will be same. Okay, diagonal matrix we already know, only diagonal element will be there, other element will be 0. Upper triangular matrix, below our leading diagonal element all are 0. Lower triangular, above our leading diagonal element everything will be 0. Identity matrix, my leading diagonal element will be 1. And for all this matrix, my determinant is simply product of their leading diagonal values. Okay, leading diagonal element எடுத்து அந்த leading diagonal element மட்டும் multiply பண்ணீங்க அப்படின்னா என்னோட determinant கிடைச்சிரும். Okay, for set of these matrices, scalar, diagonal, upper triangular, lower triangular, take the leading diagonal element, multiply the leading diagonal element, it will give me the determinant. Okay, 2. See, what about this? I hope you could recollect this. If I take a matrix A and if I multiply K is a scalar, if I multiply with A, what will happen? ஒரு ஸ்கேலார் எடுத்து என்னோட மேட்ரிக்ஸ் ஏவோட மல்டிப்ளை பண்ணணும். I need to multiply with each and every element. Okay, but for a determinant, that is a small different case. I am just doing it in a reverse way. Okay, scalar, and if I try to multiply with a determinant, I should multiply with one row or one column. Eda or row, eda or column. In this case, k has been multiplied with only second row. That is ka2 kb, sorry, second column, ka2 kb2 kc2. Or you can say in reverse way also. From one particular column I can take anything commonly out. In one particular row I can take anything commonly out. So determinant as concerned, if I multiply scalar, you need to multiply with one single row or one single column. Okay, right. Copy this. Matrices venna parallel eludhikonga. I will write down. Okay, this one I explained panadhu inge irukku. You have anyways written, right? Okay, I believe you have written, so no issues. And now consider this case. See, I will take this. We'll take this matrix. Okay, we'll take this matrix and find out determinant for that matrix. Okay, this matrix, going to find out determinant for that matrix. So determinant of K1, K2, K3, KB1, KB2, KB3, KC1, KC2, KC3, and that will be equal to what? Can I write it as K into determinant of A1, A2, A3, B1, B2, B3? K cube, yes. From each row I need to take, or from each column I need to take one k. Adana property of determinant. ஒரு element la irundhu na k veliya edukka mudiyadhu. Determinant kandupidikumbodhu from each row I need to take one k. So here, or from each column. So from this column I will take one k out. From this column I will take one k out. From this column I will take one k out. So this will be equal to k power n into determinant of the, sorry, k power, in this case k power 3, right? K power 3 into determinant of a. Okay, so if the order is 3, then it will be k power 3. If the order is n, okay, so as such here, if order is n, then determinant of k will be equal to k power n into determinant of a. Okay, just copy this, the property motto. It anyways lastly copy பண்ணிட்டு இருப்பீங்க, no problem. I feel if needed copy it also. Determinant square matrix மட்டும் தானே. So square matrix மட்டும் தான் n வந்து order. If I take two matrix, if I take two matrix 3 2 7 8 9 10 7 8 4, and if I want to add this matrix with something like 1 2 4 3 7 8 minus 2 1 4. If I want to add them, if I want to add these two matrix, what I should do? Each element should be added with other matrix basic principle. But coming to determinant as concerned, I'm just going to clean this, it's not required. Coming to determinant as concerned, a single row or a single column can be split into two. Okay, a single row. I will. There is an example, I believe. No, there is no example. I will give one example. For example, 7, 8, 3, 4, 5, 6, 4 to 1. Okay, not a matrix determinant. Okay, not a matrix determinant. I can split it as any row, any column, your wish. Okay, na example kaga na second column eduthukuren, but neenga endha column endha row venal eduthukalam. It is your wish, you can take any row, any column. So first column I am not going to split it, 7 4 4. Second column, let me take it as 3 2 1. Third column 3 6 1. Okay, it's not sufficient, but plus what I can do? The first column is not going to change, 7 4 4. Second, it's 8 here, it is 3, so it will be 5. 5 here, 2, so it will be 3. 2 here, 1, so it will be 1. So this is going to be 6, 3, 6, 1. Okay. So வெறும் ஒரு ரோவை ஸ்ப்ளிட் பண்ணி எழுதலாம் or ஒரு காலமை ஸ்ப்ளிட் பண்ணி எழுதலாம். Not necessarily column, even row also I can split it. Okay, clear? At a time la ஒரே டைம்ல பண்ணக்கூடாது. You can split it in a different steps. First ஒரு காலமை ஸ்ப்ளிட் பண்ணிடுங்க. திரும்பவும் ஸ்ப்ளிட் பண்ண ரெண்டு டிட்டர்மினன்ட் இருக்குல்ல, அதை நீங்க திரும்பவும் வேணா ஸ்ப்ளிட் பண்ணலாம். ஒரே டைம்ல பண்ணக்கூடாது. ஒரே டைம்ல பண்ற மாதிரி இருந்தால் அது மேட்ரிக்ஸ் மாதிரி ஆயிடும்ல. மேட்ரிக்ஸில் நம்ம அதானே பண்ணுறோம், ஒரு எல்லா காலமையும் நம்ம ஸ்ப்ளிட் பண்ணுற மாதிரி, அந்த மாதிரி பண்ணக்கூடாது. ஒரு காலம் ஒரு ரோவை நல்லா ஸ்ப்ளிட் பண்ண முடியும். நெக்ஸ்ட்டு see this one is something which you guys see proportional அப்படின்றத விட I will take it as dependent. Dependent row or dependent column. Okay, if there is any two dependent row or dependent column. Okay, so ஒரு ரோவும் ஒரு காலமோ இன்னொரு ரோவை காலமா டிபெண்ட் பண்ணி இருந்தது அப்படின்னா அந்த பர்டிகுலர் டிட்டர்மினன்ட்டோட அந்த பர்டிகுலர் மேட்ரிக்ஸோட டிட்டர்மினன்ட் வந்து 0. If there is a dependent row or a dependent column, then that particular matrix determinant will become 0. Here is an example. You could see 1 2 3 3 6 9 4 5 10, right? So here the first or the second one is nothing but 3 times of the first one. Row 2 is simply 3 times of our row 1. So the second row is dependent on first row. So whenever there is a dependent row present, I will make that to be 0. Determinant of the matrix will be 0. Dependent row or dependent column. Okay. Next. This one you know. If there is any 0 row or 0 column, determinant will become 0. Why? 0 row 0 column இருந்தால் அந்த row or அந்த column பொறுத்து நான் determinant எடுத்துப்பேன். If there is a 0 row or 0 column corresponding to that row, I will take determinant value, automatically it becomes 0. Okay. Okay, this one. See, this property alone you leave it. மற்ற ப்ராப்பர்ட்டியில் எழுதிக்கணும். First 3 properties write down. Fourth property I will say. இந்த ப்ராப்பர்ட்டி நான் சொல்கிறேன், இது தவிர மற்ற எல்லாமே எழுதிக்கணும். See, இந்த ப்ராப்பர்ட்டி ஏற்கனவே எக்ஸ்பிளைன் பண்ணிட்டல, இட்ஸ் ரிப்பீட்டிங். ஐடென்டிக்கலாக இருந்தால் டிட்டர்மினன்ட் 0 ஆகுன்ற ப்ராப்பர்ட்டி we have already written, right? Okay, we have written. Okay, it is just repeating. So this is not required, okay? This property is not required. We have already done it. Okay. See, before and one more thing, this is also not required because that will get confused. See, determinant of a matrix A plus or minus, that is determinant of A plus or minus B, the whole determinant will not always be, that is anyways mentioned there, but the property நீங்கள் செப்பரேட்டாக மென்ஷன் பண்ணிங்கன்னா கன்ஃபியூஸ் ஆகிடும். பிகாஸ் அதை யூஸ் பண்ணக்கூடாது. யூ ஷுட் நாட் யூஸ் இட். சம்டைம்ஸ் அது இட் இஸ் அக்செப்டட், சம்டைம்ஸ் இட் இஸ் நாட். ஓகே, ஸோ அந்த ப்ராப்பர்ட்டிஸாக யூஸ் பண்ண வேணாம். ஸோ இந்த ப்ராப்பர்ட்டி எழுதாதீங்க. ஓகே, திஸ் ப்ராப்பர்ட்டி இஸ் வேலிட். Determinant of A into B will be equal to determinant of A into determinant of A into determinant of B. இது மட்டும் எழுதுனா போதும். Okay, it is always valid. This is always valid. This is not always valid. So don't write that. Okay. And other than that, the one which we had there, last one, idukku munadi, determinant of A will be equal to determinant of A transpose. Okay, A oda determinant A transpose oda determinant same aru, right? The next one, from here it is straightforward properties. Determinant of A power n will be equal to determinant of A whole power n. Okay, that's a straightforward one. So from this I can do one thing, A inverse, and if I try to find out determinant of A inverse, and minus na veliya eduthiralamla, so determinant of A whole power minus 1, that will be equal to 1 by determinant of A. So for A inverse, my determinant will be equal to 1 by determinant of A, provided my determinant of A is not equal to 0. It's a non-singular matrix. Okay, this one is important. Adjoint of A's determinant will be equal to determinant of A whole power n minus 1. And determinant of adjoint of A will be determinant of A whole power n minus 1 whole square. Okay, இதெல்லாம் வந்து facts மாதிரி தான் இருக்கும். You have to remember from here itself. All are facts. Okay, what is a skew symmetric matrix? Skew symmetric matrix A will be equal to minus of A transpose. Odd order skew symmetric matrix in the sense its order should be odd, 3, 5 or 7 etc. So if I take odd order skew symmetric matrix and if I find out determinant for it, that value will become 0. We have taken one example also here. Okay, so we can do the determinant for this, right? So skew symmetric matrix, diagonal is 0. So determinant for this is what? 0 and 2. If I apply about first row, 0 and 2, 0 minus of minus 4, so 0 into 4. Anyway, that is going to become 0, right? Okay, 0. This one plus 1 into 0 plus 2 minus into minus minus 1 in plus 1 into minus 2, that will be equal to 0. Plus 2 minus 2, that will be 0. So if I take odd order skew symmetric matrix and if I find out determinant for it, that will become 0. One second, let me complete the balance also, then we will come back to this. This is an important one. Now the kadasi explain pandren. 3, 7, 5 and all. Okay. See, if I take an orthogonal matrix example எழுதுறீங்களா? Orthogonal matrix example. Just give me the example for orthogonal matrix. Example, 1 second. Yeah, 1 second. Determinant of A will be equal to determinant of A transpose. Okay. If I take an orthogonal matrix, cos z minus sin z, cos z. What is determinant for this? It is cos square. This is plus sin square. That's going to be equal to 1. So whenever you have a orthogonal matrix and if I find out determinant for orthogonal matrix, it will be 1. It may be plus 1 or minus 1, but it will be 1. Okay, copy this. This one you don't need to write, this one you don't need to write. Other than that,